Just so you know, you will get new seats on Monday.
New seats again?
Yeah, every 3 weeks.
Really?
Mm-hmm. The first quarter is different, but I need to learn all your names.
Oh.
So once I mostly know all of you, then I can start changing seats around. All right. Hello. Okay, here we go. We're talking about math now. So thus begins the mad rush to the end of the semester. I'm happy that it's November because then there's Veterans Day and Thanksgiving and then final exam and winter break, which I'm very excited about. Okay, already looking forward to winter break. Do you have your Christmas list going? Because I have mine.
Yes. Actually, I don't want them if I can't learn what schools. Laptop and.
So it's not for me, of course. This is a Christmas list for other kids. Like what I'm thinking of getting them for Christmas. Alright, here we go. So you'll notice we're in section 2.2 because I thought section 2.1 was stupid. So we're not going to do it. All right. And so we're going to jump right to graphing linear equations and inequalities, which I'm like, why didn't we do this like 3 months ago? So notes for next year is I'll probably be rearranging things.
Next year,
I know, guinea pigs, never fun being the guinea pig. All right, so we have a standard form of a linear equation. The A and the B and the C just represent numbers, okay? And so an example might be like 2x plus 3y equals 6, okay? So an example in standard form. There are some other restrictions that most books have, like they don't want the A to be negative. So if you had it like this, it was a -2, they would say that's not standard form. So what would you do to make it into standard form? Multiply everything by a -1. So you could multiply both sides by -1, and then it would magically turn into positive 2x, -3y, and -6, and that would be in standard form. So they're just kind of weird how people like things certain ways, but it really is more about learning what manipulations we can do in math and still create equivalence, okay? And so that's fine. Slope-intercept form, raise your hand if you've heard of slope-intercept form. Oh, very good. And what does the M stand for? Slope. And what is the definition of slope? Okay, rise over run is very good for now.
What is the
rate at which something inclines or declines.
Does.
But do you remember the formula for slope?
It's like y2
minus y1 over x2 minus x1. Good. And so, very good. Which?
I had a question. Why they go y2 and then 1? Because I always just do the first one and the second one.
Yeah, so it doesn't matter. So if you did y1 minus y2 over x1 minus x2, that's fine. As long as you're always subtracting beginning with the same ordered pair. That's fine. You cannot do y2 minus y1 over x1 minus x2. All right, that would be incorrect. Okay, so as long as you're always starting with the same ordered pair. Hi, guys. All right. Wrong time or something? Like, what happened? All right, what's the B stand for? The y-intercept. Very good. And that would be when you're graphing, anybody know why they use the letter B?
Because y is with B.
I don't know, actually.
B is the second letter from in the alphabet, and Y is the second to last.
No.
Jonah, that's a good one.
I like it. B for begin. Begin here. B for begin. Yeah.
B for bintercept?
Bintercept. Yeah. No, I really don't know why they use B, but I like B for begin here. So, all right, good. So, here we go. Example 1. The directions, I want you to graph whatever method you like to graph. But the instructions do say to find the x and y intercepts, and those are valid directions that I need you to know how to do, how to find x and y intercepts. So first of all, let's refresh here. If you have an xy ordered Cartesian coordinate plane, and I have a line here, this is my line, and it has an x-intercept right here. This would be the x-intercept where it crosses the x-axis. What is the ordered pair at this point?
Something zero.
Something zero, something negative zero. Yeah, very good. Something for x and a 0 for the y value. Okay. And then right here where the graph crosses the y-axis, this would be called the y-intercept. Okay. And what would the ordered pair be for that y-intercept?
0 and y.
Very good. 0 for x, something for the y. Okay. When you understand this, then finding x and y intercepts is really, really easy. Because here, what form is this in?
Wait, shoot.
Standard form, very good. Standard form because the x and the y are on the same side of the equals, okay? And if you want to find an x-intercept, these ordered pairs tell you exactly what you need to do. What's the y value?
0.
0. That tells you, hey, plug in a 0 for y. Well, if I do that, 4x minus 0 equals negative 4. What's x? Negative 1.
Negative 1. Yeah.
All right, so our x-intercept would be negative 1 for the x, 0 for the y. All right, so when you understand what an intercept is, those ordered pairs tell you exactly what you do. So if I want to find a y-intercept, whoops, I don't know what I'm writing there, y-intercept, that ordered pair tells you to do what?
Put y. Wait, 0 into the x.
Yeah, the x is 0. So I'm going to go to my equation and I'm going to do 4 times 0 minus y equals negative 4. Which means y equals?
4. Positive.
Oh, no, positive 4.
Positive 4. Very good. Okay, so that was a 0 placed to the x and a 4 for the y. When you're in standard form, finding x and y intercepts is super easy. And in fact, we call it the cover and solve method. So if you want the x-intercept, you cover the y and solve for x. And if you want the y-intercept, you cover the x and solve for y. All right, so the cover and solve method, super easy. And then to graph the line, how many points determine a line? 2 points determine every single line. So we have 2 points, and you can plot those 2 points. Negative 1, 0, 0, 4, and then connect them with a straight line, and you've graphed your line.
Yeah.
All right. So graphing in standard form is very, very easy to find the intercepts. Okay. You stretching? Okay, Jacob.
I was curious. Is graphing something that you want us to do?
You must graph. It tells you to graph. Yes.
Oh, it does.
Graph. That's very explicit. Graph. It's not an option. It's a command. All right. What form is this function in? Not standard form. Slope intercept form. All right. And so if you wanted to graph in slope intercept form, you could, which I will do because it's in slope intercept form. But first, we still need to find, because the instructions do say find the x and y intercepts. So for the x-intercept, how do I find an x-intercept? Set y equal to 0. All right, and so now we need to solve for x, which means I need to do what? Add 1, 2/3 x, And then what? Multiply by 3 over reciprocal, 3 over 2. Very good. So we get x equals 3 over 2. My x-intercept then would be 3 over 2 for x, 0 for y. So finding the x-intercept, not so easy when we're not in standard form, but it's doable. How do I find the y-intercept?
It's B.
X equals 0.
Oh, the y-intercept is when x is 0, which turns out to be -1. Sure. All right, so you can do the math or know this is slope-intercept form, which means the y-intercept, the b value is -1. So 0, -1. If you can see the answer right away, do you need to show all of this work?
No.
Lord, no. Okay, I'm the only math teacher in the world who's ever going to tell you to do as little work as possible. Okay? All right? But don't do it wrong now. All right? As long as it's right, you can do as little work as possible. Okay? All right. So you can 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. If you wanted to, we could plot these 2 points and label them, and you're done. I'm going to just graph using slope-intercept form just to remind you. So y equals mx plus b. The b is -1. So that is the y-intercept. We start at -1. B for begin here. You put a big giant beginning point there. And then the slope, the m value is, slope is rise over run. It tells you to go rise up to and run 3 units. So we're going to rise to and run 3. Now, ladies and gentlemen, the way that I do slope, the rise is going to take any sign. It's going to tell you to go up or down. Up if it's positive, down if it's negative. When I do this, the run, it always runs to the right. Run always runs to the right. Okay? Can you go in reverse? Sure, but both ways. Okay. I have too many students when I would teach this in algebra who'd be like, they go rise 2 and then go left 3, which that's not going to give you the proper slope. Okay. So here is our slope. Here you can see pretty close. Now I'm graphing by hand. That should be the point 3/2, 0, 1.5, 0, which is pretty close. Okay. What's the slope of that line? Positive or negative?
Positive.
Yeah, it's a positive 2/3. It's going uphill from left to right. Please double check to make sure your slope is proper. Okay, matches. Do you have any questions for me?
Nope.
All right. We're not quite done, but the rest are pretty easy.
I thought that's what that meant.
I know. So did I. I thought we were done, but we're not. It's a good thing I do these things ahead of time. All right. X equals 3. Special case line. What's the x-intercept?
Oh. 3, yeah.
Yeah, x is 3. 3 at the 0. Okay. There is an x-intercept of 3, 0. What kind of line is this?
A vertical line.
Vertical line. I do like to talk about that. Anytime you have x equals a number, it is a vertical line. And by default, then, if it's y equals a number, that's going to be a horizontal line, okay? I want to talk about this slope. I want to make sure you all understand why this equation makes sense. Because this is like the most important thing to me. What is the equation of, what's the ordered pair for this point there? 3, 1. Good. All right, what's this point?
3, 2.
3, 2. What's this point?
3.
What's every point on this line forever?
3.
X is always 3.
X is always 3. Do I care about the y at all? No, I do not. That is why this equation makes perfect sense. All right. Have you heard that before?
No.
Did you like that?
Yeah.
That's pretty good, right? I mean, there's logic in math. How about that? Okay. So it.
If you write that, they just. Okay.
Just with the alphabet, just
Makes total sense. Okay. The last thing, you guys have a few problems that are graphing linear inequalities in two variables. To graph these, I think the easy thing to do is just rewrite them in slope-intercept form. So I want to isolate the y. What should we do to isolate the y?
Add minus subtract. I've been in the sun all day.
Oh, I see. Okay. Subtract the x. All right, and then do what? Divide by -2 everywhere. What do I have to do when I multiply or divide by negative? Flip the inequality. Very good. So I get y is less than 1/2 x minus 2. So this is in slope-intercept form. So I am going to go ahead and graph that. And then just like the other inequalities we were solving, we have to do open or closed and then shade above or shade below.
Exciting.
All right, so because it is simply less than, it is an open circle, but we don't have a circle, we have lines. So how do we make an open line?
Dash.
A dashed line. Very good, very good. All right, so my b is at -2. B for begin here. And what's the slope? Up 1, right 2. Up 1, right 2. Up 1, right 2. And then we do a dotted line or a dashed line because it's an open line. It means it's not included in the answer set. Not a solution. Nothing on the line actually works. Okay?
That's depressing.
It's a boundary line. And so we want to know where are the y values less than the line? Under the line. So we shade under the line. How do you know if you got it right? Is there a way you can check it?
You could just plug in a random point that's under the line.
Yeah, so we could plug in some points to check if you wanted to. It's a good strategy on a test, like for instance yesterday's test. If you didn't know how to solve it, you could have picked a point in the solution region and plugged it in and tested it. So I could test this point. It's 1, 2, 3, 4, 5, 6, 6, 0. And I would plug that in and see if I get a true or false statement. Now you'll notice I'm going to plug it into the original. 6 minus 2 times 0 is greater than 4. Is 6 greater than 4?
Yes.
True, which means this is the correct shaded half plane. Okay. All right, ladies and gentlemen, do you have any questions for me? Great, so do your work. I'm sorry?
Fancy cheese.
Cheeses?
Yeah.
No, sorry.
You have made for your fancy cheeses or something?
I do have fondue in the freezer.
Whoa.
Fancy.
I don't have a freezer here. It's at home.
Oh.
We keep fondue on hand
For when students are hungry.
Do you fondue?
I don't have any so on that. Yeah, that doesn't make that long.
Here we go. Just another day, nothing is
make a joke to Sarah Bentley, and I go, how do they?
Hey, New York guys, you need to turn it in before you leave.
I'm sorry, but he's like, towards the end,
What if he got back to 62 years old?
he's like, he's like very you're really wanting to be server, start walking.
Oh.
Okay, here's my She's got the job?
Hey, it's November
We are
1st.
I forgot my keys today. Yeah, I forgot my
You know how much I like food if I just move my entire body through that.
All right, guys, you get this done before you leave. You're turning it in before you leave.
I'll leave it at that.
Oh,
Or freaking
Wow, it's actually
I
just if you have